call supplementary cementitious materials, or SCMs, things like fly ash and slag.
CMs. Okay, so like secret ingredients for super concrete.
You could say that they basically react with the cement to create a denser, stronger material.
Okay, so from super strong, we move on to super light, lightweight concrete.
Right. And it's not that it's not strong, it's just, well, lighter. This is super helpful when you're worried about the weight of a structure. Think of things like roof gardens or balconies.
Makes sense. So you don't want a heavy concrete slab weighing everything down.
Exactly. It's about finding that balance between strength and weight. Like, you wouldn't want to carry around a whole stack of encyclopedias if you could have all that info on a lightweight tablet, right?
Great analogy. Now, onto something that sounds almost too good to be true. Self-healing concrete.
Right. It sounds like something out of a sci-fi movie.
It really does.
Mm.
So how does it actually, heal itself?
Well, there are a couple of ways. One is to use bacteria that produce limestone. When a crack forms and water seeps in, the bacteria become active and literally seal the crack.
No way. So it's like the concrete has its own immune system?
Pretty much. Another method uses microcapsules filled with a healing agent. When the concrete cracks, the capsules break open and release the agent, which then hardens and fills the crack.
That's incredible. I imagine this is a game changer for structures like bridges and tunnels where repairs are super disruptive and expensive.
Absolutely. And don't forget underwater structures where repairs are even more challenging.
Okay, so moving on to another type of specialized concrete, fiber reinforced concrete, or FRC. What can you tell us about this one?
Well, as the name suggests, it involves adding fibers to the concrete mix. These fibers can be steel, glass, or even synthetic materials.
So it's like reinforcing the concrete from the inside out.
Exactly. The fibers act like tiny little reinforcing bars, which dramatically increases the concrete's tensile strength and its ability to resist cracking.
So where would you typically use this type of concrete?
You'll often find it in industrial floors that need to withstand heavy loads, like in factories and warehouses. It's also used in roads and bridges to make them more durable.
So this is the super tough concrete. And then we have ultra high performance concrete, which is what? Even tougher.
Think of UHPC as the ultimate concrete, the one you use when failure is simply not an option. It's incredibly strong and durable. We're talking bank vaults, nuclear containment structures, that kind of thing.
Wow, okay. That definitely sounds ultra high performance.
And the applications reflect that. It can even be used in bridges with longer spans, reducing the need for as many supporting piers.
That's amazing. It seems like the possibilities with concrete are almost endless, but of course we have to consider the environmental impact.
You're right. Traditional concrete production does have a significant carbon footprint, but that's why we have things like permeable concrete, which is designed to be more sustainable.
Right. Permeable concrete, I've seen that around. It's the one that lets water soak through it, right?
Right. Exactly. It helps to reduce runoff and prevent flooding. Plus, it can help to replenish groundwater supplies. It's a great example of how we can engineer concrete to be more environmentally friendly.
So from self-healing skyscrapers to eco-friendly pavements, it's amazing to see how concrete technology is evolving.
Absolutely. And who knows what incredible innovations are on the horizon for this versatile material.
I can't wait to find out. Thanks for joining us for this deep dive into the world of specialized concrete. Okay, I'll admit, when I think concrete, I picture, well, sidewalks, buildings, not exactly the most thrilling stuff.
Yeah, you don't exactly picture innovation, right?
Exactly.
Yeah.
But we're diving deep into concrete today, and let me tell you, after this research, boring is the last word I'd use.
It's mind-blowing, actually. The tech coming out, what this could mean for how we build cities could be radically different.
No kidding. We've got articles, sustainability reports, even some military documents about this stuff, ready to push the boundaries.
Let's do it.
So first off, when I see self-healing concrete, I think, okay, what is this? Sci-fi. But it's real.
And it's as wild as it sounds. Imagine bacteria, like the tiny stuff, are mixed right into the concrete itself.
Get out of here. So what, these little guys are like construction workers.
In a way, if a crack forms and water gets in that activates them, they start producing this limestone-like material.
Hold on. So they basically heal the crack from the inside out.
Pretty much. And this isn't some temporary fix. This is legit extending the lifespan of, say, a bridge by potentially centuries.
Centuries. Okay, the cost savings alone on repairs, that's got to be huge.
Massive. And the environmental impact. Way less waste, way fewer materials needed long term. Sustainability gold mine.
Which is a perfect segue because then there's recycled concrete,
Hmm.
right? We're not just stuck making new stuff endlessly.
Right. Demolishing a building instead of landfill bound rubble, we're talking about grinding that concrete up, processing it.
So it's not just like chucking chunks of old sidewalk into a new mix, right? There's got to be more to it.
Oh, absolutely. It's got to meet specific standards, different processing techniques. But the core idea is reusing what we've got.
Makes you wonder why we weren't doing this all along. I mean, talk about a no-brainer for sustainability.
It's gaining traction, especially as we realize how crucial all this is for the environment.
And then there's the smart aspect, sensors embedded right into the concrete. It's like giving buildings a nervous system.
That's a great way to put it. Think about it. These sensors are constantly monitoring for tiny changes, things we'd never catch.
So stress from weight, temperature swings, even stuff like what, rust or cracks, forming way before they become a problem.
All of that. And that data. It's transmitted instantly. Engineers get real time updates on the structure's health.
Meaning a bridge could basically tell us it needs attention before anything major goes wrong.
Precisely. Talk about a game changer for safety, for maintenance. The possibilities are huge.
Huge is an understatement. And we haven't even gotten to the stuff that sounds straight up impossible, like air purifying concrete.
You think I'm kidding, right? But nope, this is real. One of the biggest culprits of greenhouse gases, concrete production.
Yeah, I've heard that. All those chemical reactions, right? So